now's the fun part. We're going to put this into our calculator, let our calculator do all the arithmetic for us. So we can know how to turn our system of equations into an augmented matrix. In our calculator, we're going to hit the keys second matrix. And then we're going to cursor to the right over to edit and hit enter. And then we're going to enter this as a 3 by 4 matrix. So just hit enter after each entry. 3, enter, 4, enter, 0, enter, 3, enter. When you've got all the elements in, second quit to get out of there. And then I like to go ahead and display the matrix. So you can do that by hitting second matrix again, and then just hit enter, or matrix 1, and then hit enter a second time, and it'll display the matrix for you. Okay, now if you hit second matrix, cursor over to where it says math, you've got a bunch of words there. Scroll down until you get to option A and B. Option A is REF, which is row echelon form, what we were just doing. And option B is RREF, reduced row echelon form. So first let's take a quick look at REF. So get your cursor so it's on the A and hit enter. Then hit second matrix and enter, or 1 or enter for matrix A, and then hit enter again. And you'll get something that looks like this. Doesn't tell us much. If you then hit math and then enter, it'll change those repeating decimals into fractions. It's a little easier to see what we've got there. But I actually had to cursor over sideways to see the far right-hand side of my matrix. So looking at the bottom row, we can recognize the z equals -2 that we had before. And then we could back substitute here, because we've got y subtract 5/3 z is 1/3. Calculator came up with a slightly different result than I did, because I did a row swap and saved myself from some fractions that it didn't do. And then we could go and find y, etc. But here's the cool part. Go back, hit second matrix again, go over to math, cursor down to option B there, the RREF. That's the reduced row echelon form. You're going to like this one. So when you've got your cursor on the B, hit enter, and then second matrix, 1 for matrix A, and then hit enter, and you get this result. Okay, now if we translate that back, 1x plus 0 equals 1. X equals 1. 0x plus 1y plus 0z equals -3, or just y equals -3, and z equals -2. So we don't have to do the back substitution if we do the reduced row echelon form. Okay, a couple more examples. I pulled these out of the textbook. So I've got a matrix, system of equations here, put it in as an augmented matrix, did my reduced row echelon form, and there's my solution. It took me, I don't know, 15 seconds. And then my second one here, so I can get that out of the way so you can see it. Okay, I think this is number 34 in the book, so this is my systems. Typed it into my matrix A, did my reduced row echelon form, and then take a look at what I've got here. So the bottom row is not saying z equals 1, but the bottom row is actually saying 0 equals 1, which is not true, so this is our no solution case. Okay, and then my third example again, type this into your calculator. Matrix A is the augmented matrix. Hit the reduced row echelon form. And here, notice my bottom row is all zeros. So that's saying 0 equals 0, which is true. Not really informative, but true. So this is our infinite number of solutions case. So what we can do is just arbitrarily decide to let z equal c, or z equal t, or z equal some constant. Then we can describe x and y in terms of that constant. Since y subtracts z equals 2, I just change that, substituting in c for z. Solve for y and get y equals 2 plus c. Same thing with the x. I have x subtract 2z equals -1. I'm letting z equals arbitrary constant c. Solve for x, and I've got x equals -1 plus 2c. So I can describe my solution set this way. Let's see, how much time do I have left here? Let me go ahead and pop back and just show you a couple story problems that the lecture class had asked me about. This is one that's in the book. It's a plane flying into the wind. So when a plane's flying into the wind and going with the wind, The total speed of the plane is the speed of the airplane plus the speed of the wind. When an airplane's flying against the wind slows it down, and p subtract the speed of the wind is the total speed of the plane at that point. So flying with the wind, the plane was able to cover 450 miles in 3 hours. Flying against the wind, the plane was able to fly that 450 miles in a total of 5 hours. And then we know distance equals rate times time. So we're able to set up the system of equations. 450 equals the speed of the plane with the wind times the time 3. 450 equals the speed of the plane against the wind times the time of 5 hours. And we can solve the system from there. And then another story problem that was out of the textbook homework. I had a bucket of coins with nickels, quarters, and silver dollars. We had a total of 740 coins, excuse me, it's been a long day, and a total value of $157. We're also told there's twice as many nickels as quarters. So if we let n be the number of nickels, q the number of quarters, d the number of dollars. So this is just number pieces of shiny circles of metal. Whereas 0.05 n is the value of the nickels, 0.25 q is the dollar value of the quarters, and 1d is the value of the dollars. So the total number of coins was 740, and the total value of the coins was $157. And then the one we had to think about a little bit was there's twice as many nickels as quarters. So I kind of played with the numbers when we were in class. Said if there's 10 nickels, if there's twice as many nickels as quarters, then 10 nickels means 5 quarters, 100 nickels means 50 quarters, 20 nickels means 10 quarters. We kind of played with the numbers until we realized the relationship was the number of nickels is twice the number of quarters. That's how twice as many nickels as quarters translates into algebra. You can think about it a little bit. So then moving it over, we then have the equation n subtract 2q equals 0. And hey, we could just put this in our calculator and solve it now, couldn't we?